Good evening, friend. Welcome to this course lecture series for manufacturing technology. Second unit, first lecture 15, metal cutting operation. In this series, in this video, find out the value of the tool life and the other is the parameter. Find out the value of this operation. Agenda for today in the solve the examples of the numerical problem as this the before apply for this analysis of the formula and based for the value of experiment and analysis. The the problem is the a 600 long job of the diameter 150 of the AISI for 4140 steel is to be turned with the depth of cut of the 1.5 mm and feed rate 0.25 mm per revolution. The following data is applicable for the problem. Labor cost per hour is 12 rupees and machine overhead per hour is 40 rupees and grinding cost per hour is 15 rupees. Grinding machine overhead per hour for the 50 rupees and ideal time 5 minutes. Okay, ideal time is given for the 5 minutes and the Taylor tool life of equation is given for the Vt की power 0.2 to equal to 750. 475. The operation can be carried out the using the tungsten carbide tools. In this application of this operation is application of the tungsten carbide tools and other the branch tools also the for the branch tools. Initial cost is the 60 rupees. Grinding time of the 5 minutes per each. Okay, tool change time 2 minutes and 9 grants for tools before for the solve. Okay, all the value is given for in these problems and so for other steps initial cost is 440 rupees and tool change time is the 1.5 minute and tool change is 8. Find the optimum cutting speed, tool life and cost of the operation for both of the horse tips of the through any types using the following criteria. To find out the only for two values in this problem for minimum production cost and second is the value of maximum production rate. Okay, the comment for the result obtained all the problems is given for the data and first is the Taylor two-love equation is n equal to given for the value is 0.22 and c is the constant value 475 r is the number of grams. Ideal time equal to loading time and unloading time of the adiabatic time of the equal to 5 minutes. Overhead cost is C naught and 1200 plus 40 equal to 5200 per hour. The change of value is the in minute. The divided by the divided to the 52 upon 60 equal to value for given for the value is 0.866667 rupees per minute. Okay, the bronze tools, this value for the bronze tools is the tool grinding cost. The tool grinding cost is the formula apply for the formula. TA is the ideal time कोष्टक and TA is the ideal time and the of the grinding cost per hour plus and grinding overhead per grinding cost per hour plus grinding cost of the overhead upon 60. So all the value is find out the in minute, then the value is divided by the 660. The 5 cost 115 plus 50 equal to value divided by 60. The value of find out the value is the value of the tool grinding cost is the 5.417 rupees and tool cost is CE. The tool cost of the 60 tool cost formula 60 plus this is the value is given for them and T is the grinding cost 5.417 into N is the number of grinds upon 10. Then the tool cost is C value given for the value is 10.875 rupees. Other parameter find out the value of this equation and this is the other value tool change time is TC equal to 2 minutes given for in this problem. The maximum cost criteria for the find out the value of optimum cutting speed. Value of V equal to formula given for the formula C C naught upon CE plus TC plus C naught n upon 1 minus n whole of कोष्टक के power n. Putting for the value of the C value given for the in to Taylor equation, the C value for 475 कोष्टक. Putting for the C naught is the value of the over total cost 0.8667 upon C is the overhead cost या total cost. C is the average cost या total cost. The 10.875 plus 20 points. The C naught is the given value for the 10 point value for the 10 point. C naught is value for given. This is value for the 10.875 into 2. The value for the 20.8667 कोष्टक putting for the value of n 0.22 upon 1 minus 0.22 के power 0 के power n 0.22 given for the value optimum cutting speed V equal to 1199.5 meter per minute. The optimum speed V equal to 199 point and 199.5 19 meter per minute. Find out the value of optimum tool life T. Find out the value of T. The formula for putting for the formula C naught plus CE upon C naught 1 minus n upon n. Putting for the value C naught is the change of tool time 2 plus CE is the value for overhead cost 10.875 upon C naught is the 0.8667 cost of 1 minus putting for the value of n 0.22 upon 0.22 for the the putting for the value in C for calculate the value of optimum tool life is 51.58 minute. Okay, the tool life of this value is 51.58 minute. Machining time, find out the value of machining time. Tm equal to pi dl upon 1000 f into v. Putting for in this value for pi into d is the diameter of the job 150 into L is the length of the bar is the 600 upon 1000 into F is the given for the value of feed rate 0.25 into find out the value of the optimum cutting speed V is the optimum cutting speed, find out the 1.199.5. The total, find out the value of this is the machining time is given for the 5.669 minute. Okay, 5.669 minute. The machining time of T is equal to this other value. Find out the value of total time of the operation in the T1 is the loading time and TU and unloading time, and TA is the term of the time, and T is the T naught upon P plus Tm cosec 1 plus Tc upon capital T. Putting the value of the ideal time, total ideal time 5 plus, and Tm value is the 5.669, and the 1 plus 2 upon Tc is the tool change of time, T2 upon Tm is the total tool life of the tool life 51.58. Find solve this value is the given for the value of total time is the 10.89 minute. Okay, satisfies this value of the given. The find out the other value of the cost of the operation, total cost in the operation. Okay, so C naught plus idle time plus T naught by P plus Tm is the T is the overhead cost plus Tc is the tool change of time into C naught is the overall cost. Okay, the putting for the value of C naught 0.8667 into ideal time 5 plus total the total time machining time 5.669 postal CE is the find out the value of overhead cost is the 10.875 plus TC is the value given for this question 2 into C naught is the overall cost 0.8667. Find out the value in this multiplication and addition part, the value is the 10.63 rupees. Okay, the cost of operation in this operation for the value 10.63. Second value, find out the second value for the maximum production rate criteria. Okay, the optimum cutting speed V equal to in this operation V equal to C cost n upon Tc 1 minus n upon k power n. Putting for the value of the C is constant value 455 cost 0.22 upon 2 into Tc is the tool change time. Okay, cost for 1 minus 0.22 k power 0.22. Putting for the value is given is approximate 308.7 minute per meter per minute. Okay, the optimum cutting speed is the 308.7 meter per minute, and the optimum tool life, find out the value of optimum tool life in this operation. T equal to Tc, putting for 1 cost of 1 minus n upon n. The value of putting in this formula to Tc is the 2 and cost of 1 minus 0.22 upon 0.22. The value for the optimum tool life is the 7.091 minute. Okay, minutes. So the optimum tool life is 7.091 minutes. Okay, machining time, total machining time on this operation tm equal to pi pi dl upon 1000 fv. So putting this value, find out the pi into 150 is the diameter of the job, and length of the job 600 upon 1000 into 0.25 into putting for the value of this is the optimum tool life tq, optimum or the optimum speed cutting of the v equal to value of 308.7. Putting solve this value is the machining time is the tm equal to 3.664 minutes. Okay, other value, find out the total time, find out the total time and the ideal time plus machining time, and the other form 1 plus 2 upon is the t is the optimum tool life. Putting value is the 9.697 minutes. Cost of operation, total cost, find out the total cost in this operation. C naught, C naught कोष्टक idle time plus T naught YP plus time machining time plus C upon to overhead cost plus C naught is the C TC is the tool change time of one, and C naught is the overall cost. So C naught value, find also find out this before 0.8667 into ideal time 5 minutes plus, and that time is the machining time is the also find out the 3.664 costa. T is the ce is the find out value also before the formula 10.875 plus tc is the 2 value given for the value of 2 into 8.8667. The for in this solve this problem, solve this step for the given for the value 14.2 rupees. Okay, through far away for the tools in using for this formula, the tool cost ce is the tool cost, find out the small value for the tool cost over the overhead of the tool is the 40 rupees upon number of tools is 8 per hour 5 rupees, and the change of the tool change time tc is 1.5 minutes. Putting for the value is the maximum cost criteria for the optimum speed cutting speed, find out the value of v 4.75. Hashtag 0. C is the value of 0.667 upon 5.1.5 into 0.866, and other value, find the value of n. Putting the value of 0.22 upon 1 minus 0.22 की power 0.22, this value solve this value कोष्टक for this value is given for the optimum cutting speed 232.4 minute per meter per minute. Okay, find the only for value the putting for this value on a meter per minute he. Okay, the 232.4 meter per minute. Okay, find out the value of optimum tool life. Optimum tool, the t equal to TC plus TC plus idle time upon C naught upon 1 minus n upon n. The putting for the value is the TC is the in this given value for the 1.5 plus 5 upon idle time given for this problem is the 5, and find out the value of C is the 0.8667. The other question, putting for the value in small formula 1 minus 0.22 upon 0.22 k power, the find out the value of t in optimum tool life is the 25.77 minute. Okay, the total tool and the optimum cutting speed is the 232.4 meter per minute, and optimum tool life t is value for using 25.77 minutes. Okay, continue present for the machining time tm is find out the value of in this the value of putting for the 5 into dl upon 1000 in f into v is the value for the optimum tool speed. Okay, the find out the value of pi into 150 into 600 upon 1000 into f is the given for the value in this problem for 0.25 given for the feed rate and optimum speed of the 232.4. Find out the value of the machining time 4.866 minutes. Okay, the total time find out the value of total time 5.4.866 cost of 1 plus 1.5 upon 2.25.77. Find out the value of the 10.149 minutes. The other value, find out the other value cost of the operation in this the c naught into ideal time plus machining time on Kotak for the ideal time plus TC value for the given for C naught, putting for the value is the 0.8667 into 5 plus 8 point machining time 4.866 Kotak 5.1.5 into 0.8667. Solve this problem is the given for the value is 9.74 rupees. Okay, find out the other step for this problem is the maximum production rate in this. Okay, the maximum production rate is the find out the value of optimum cutting speed v equal to c. C is the constant value and n upon tc into 1 minus n e power n. Putting for in this value the 475 Koshtak 0.22 upon 1.5 into 1 minus 0.22, okay, power 0.225. The putting for solve this problem is the given for the value optimum cutting speed 328.87 minute meter per minute. Okay, the optimum cutting speed and find out the optimum cutting speed 328.87 meter per minute. Okay, find out the value of optimum tool life. Find the value of t. The tc is cost of 1 minus n upon n. The given for 1.5 is the tool change of time upon 1 minus 0.22 upon 0.2. Find out the optimum tool life t equal to 5.318 minutes. Okay, other far factor is given for the value of machining time. Find out the machining time of this formula pi dl upon 1000 f into v. V is the value of the optimum speed of the tools. The putting for the value 5 into 150 into 600 upon 1000 into 0.25 into putting for the value of V 328.787, this for the value of the 304.39 minutes. Find out the value of total time is the ideal time plus machining time plus 1 plus n upon of the total tool life. Okay, the value for putting for the 5.0.3.439 cost of 1 plus 1.5 upon 5.1318 value for the 9.409 minutes. Cost of operation, total cost in this operation for the C naught plus idle time plus machining time in Kotak for the TC plus 5 into idle time plus machining change of tool TC into C naught. Putting for the value is the solve the problem is the 11.388 rupees. Importance parameters, the sum of the consideration or assumptions on this formula and the sum of important factor in this operation in in the set for on the mind for the operation, the maximum cutting power available at the machine of the tool spindle and the maximum cutting forces is the permissible in this operation. The surface finish and the diametric for tolerance to be achieved on the machining surface. And other point is that the limiting limits of the speed, feed rate, depth of cut improve by the machining tools and the cutting tools. All the constant maximum permissible cutting parameters also constant maximum permissible cutter, maximum permissible work pieces, the static and dynamic instability both are the reason is constant tool life and tool fracture. The summary of this continues the power constant. What is the power constant? Given for the power of supply to the power in the uh, production production rate and the operation in the machine for the power constant assumes the significance only for the rough machining and hence the continuous operation provide the production in the operation for the continuous. This is the given requirement of the power is constrained supply of power. The power should be exceed maximum power. Okay, find out value of maximum power. V k power AF upon F k power PB D k power CP upon KC upon 6 into 1000 into N. N is the above expression for the value of specific cutting forces is constant for the particular work or for the materials in the CP or V k power A or F k power B and D k power CP is greater than maximum power. Okay, all the value of the is less for the maximum power and find out the value of CP Kc upon 6 into 1000 and efficiency of the machine. Surface finish constant. Find out the value of the surface finish constant. This constant limit for the maximum feed that can be used for attains the required surface finish is the value of the requirement of the formula. A specific it's the surface finish constant 1000 into F given for a feed rate square upon 18 under root 3r. R is the radius of the uh, radius of the cylindrical workpiece and based on the surface finish is the maximum speed on the return surface. The constant on feed can be expressed as the CS in the F feed rate square is greater than the SF is the maximum. Okay, the CS is the find out the value of 1000 upon 18 under 3r. The putting for in this value or putting the value of r and the find out the value of CS. Okay, the surface of finish constant. Okay, the this is other important formulas used in this factor. The maximum and minimum speed constant. The maximum speed constant is determined as the longer of value of the minimum cost. The minimum cost speed for the machine tools and minimum cutting speed due to the cutting tools is the V minimum. Okay, for the putting for the value is the max upon pi dn minimum of pi d n is the minimum number of the revolution 1 upon 1000 comma v mean the is the greater than v is the this is the whole factor of the greater than v and v is also greater than pi dn max upon 1000. Okay, the minimum speed and maximum speed, maximum and minimum speed constant. The maximum speed permissible for the requirement of the cutting tools is the f feed rate of maximum is set on the recognition for given putting for the cutting tools manufacturer as these the recommendations of the feed rate is maximum set on the machine exceed for the 0.4 to 0.5 times of the insert corner radius of the rectangular insert for the 0.6 to say 0.7 times of the corner radius of the square insert. The minimum set for the minimum feed rate is greater than f and minimum of the other is the maximum feed rate and the maximum feed. Okay, thank you so much.